In this unit, we are going to define some standard ratios in a right triangle. Because given a right triangle, we always know that all right triangles share one angle, and then any two that have another pair of corresponding angles, you know those triangles are similar. So their sides are all going to be in the same ratio. If I have a right triangle here with a certain angle, and then this is going to have to be its complement, every right triangle that has the same corresponding congruent angles for angle A and then for angle B, they are all going to share the same ratios because corresponding sides are always going to be in the same ratio. That's what we learned about similar triangles. So we're going to define those basic ratios, and we're going to give those ratios special names because we use them over and over and over again. Right triangle, analyzing right triangles is a very, very useful tool, believe it or not. It shows up everywhere outside of this geometry course, actually. So we're going to start off by naming some of these sides of a triangle and giving them special names. For starters, you know, in our right triangle we have right here, if angle C is 90 degrees, then we have the side opposite the 90-degree angle is the hypotenuse. We all know that, so we're going to keep using that. And then the other two legs are labeled relative to the angle we're talking about. So if we're talking about angle A, we have a leg that makes up part of angle A, that's right next to the angle. That's going to be the adjacent side. So the leg adjacent to angle A is going to be AC. And then across from angle A, we're going to have the leg that's called the opposite. So BC is the opposite leg from angle A. So the leg opposite angle A is BC. Now all of that's relative to angle A. We could do the same thing from angle B. The hypotenuse stays the same, but now the side adjacent to angle B is going to be BC. So we'll say the leg adjacent to angle B to angle B is BC. So they switch places, and the leg opposite angle B is AC. So the way we label the legs is completely dependent upon which angle we're talking about. We know our 90 degree isn't going to change, but these angles will be complements of each other. And depending on which angle we use, that's going to determine which side is adjacent and which side is opposite. So now we're going to define some ratios relative to one angle. And I call this angle, the symbol for this is theta. We've talked about this before. The standard symbol, it's a circle with a line through it, and that's pronounced theta. And that's usually how we represent an angle. So we're going to talk about the ratios relative to this angle theta here. In my right triangle, of course, this is always the hypotenuse, the side opposite the right angle. The side adjacent to theta is the one that helps create theta, that's adjacent. And then across from it is going to be opposite. This is what we're going to have to do when we use our trig ratios. So we have three basic trig ratios that we're going to define now. So we're going to start with the one that's called sine, S-I-N-E. The sine of an angle, because it's just a name, that's defined as the opposite side over the hypotenuse. That's the ratio. Because remember, we're talking about ratios because we're talking about similar triangles. So the sine of an angle is defined as the opposite over the hypotenuse. That's the ratio that we deal with when we talk about sine. And remember, the opposite depends on what angle you're talking about. Up there, we would write it as this, the sine of theta. S-I-N is the shortcut. So sine is opposite over hypotenuse. Then we have cosine, That's a different ratio. The cosine is going to be the adjacent side over the hypotenuse. Let me see if I can spell adjacent right. Adjacent over hypotenuse. And its shorthand version is COS, the cosine of theta. So the cosine is adjacent over hypotenuse. And then we have the tangent. The tangent is going to be the opposite side over the adjacent side. Opposite over adjacent. Its symbol is TAN, the tangent of theta. So the tangent of theta is opposite over adjacent. You're going to have to work with these ratios quite a bit, so it's good to memorize them. And one way to do that is to look at the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. It kind of spells SOHCAHTOA, or some old horse caught another horse, taking notes away. That's one way to remember these ratios, but these are very special ratios that we're going to use over and over and over again. So you are going to have to know them very well. So today we're going to work on how to find an angle measure using these special trig ratios. Now, for every angle measure, every type of right triangle that we have, there is a specific value for sine, cosine, and tangent. And it used to be a long time ago we'd have to have these giant tables of values that we would have to look up. But now we have our calculators, so all those values are in your calculator. And makes it a lot easier than looking up tables anyway. So I'm going to write the steps to find an angle measure, and then we'll walk through a problem. So the first thing you need to do is, relative to the angle you're dealing with, you need to label the sides of the right triangle. And the way you're going to label it is you're going to find the hypotenuse, and then relative to the angle you're dealing with, the opposite side of that angle, or the side opposite that angle, and the side adjacent to that angle, because that's how you're going to set up all your ratios. Then you're going to look and see what you have and what you're trying to find, and you're going to set up the appropriate trigonometric ratio. Again, you can use some old horse for sine, caught another horse, taking oats away, to determine whether you need to use sine, cosine, or tangent when you set this up. And then what you do, which is what I'll show you in class, you're going to use the inverse function on your calculator to solve for the angle. We'll have to make sure our calculators are in degree mode, and we will set all this up in class. So let me just walk through an example to explain these steps again. If I have a right triangle, and this right triangle has an angle B that I want to solve for, or actually I'll call that theta, because that's what we got to get used to doing, is using theta. And this triangle has a side of 3 and a side of 4. So what we do, step one, is that we want to label the sides of the triangle. Opposite the right angle is hypotenuse, and then if I'm dealing with this angle theta, opposite theta, that's going to be the side, we're going to call that side opposite, and then this one is going to be adjacent because it's right next to theta. So once I have that, that's my first step. Second step is to set up the appropriate trig ratio. Well, if I only have the two sides here, I'm kind of locked into what trig ratio I can use. Relative to this angle, I have opposite and adjacent. So when you look through here, you look for which one has opposite and adjacent, and that's the TOA, that's tangent. So we choose tangent to set this up. The tangent of theta is equal to 3 over 4. That's the opposite over adjacent. And then finally what we do is we use the inverse tangent on the calculator to solve. So what you would actually be choosing on your calculator, your answer ends up being tangent -1 of 3 over 4. That's a button on your calculator. It's second tangent, and when you solve that, it ends up being, theta ends up being 37 degrees if you round to the nearest degree. So that's the basic process for finding an angle measure. Okay, here's a different type of example. We have a right triangle, and this time it's RST, and we have the three sides known, but my instructions say find the measure of angle S using the sine function. So let's label our triangle relative to angle S. Across from The right angle is the hypotenuse, so always across from the right angle is the hypotenuse. Now, relative to angle S, this side up here is going to be adjacent because it helps create the S. And then the side far away is going to be opposite. So think of your sign. Think of SOHCAHTOA, some old horse caught another horse taking oats away. Sine is opposite over the sine of S is going to be the opposite side over the hypotenuse. So now you just look at your diagram, and sine of S is going to be opposite as radical 3, and the hypotenuse is 2. So then we would use our calculator in the inverse sine function, radical 3 over 2. Make sure, depending on what calculator you have, this radical 3, if it's parentheses, make sure you close the parentheses before you divide by 2, otherwise you won't get the right answer. Because we don't want to take the square root of 3/2, we want to take the square root of 3 and then divide by 2. So once you put that in your calculator, you would end up with angle S is going to be 60 degrees. Alright, for the last example, it's the same type of triangle. I have a radical 3 and a 2. I'm going to find the measure of angle R. So in this case, if you're only given two sides, you're more restricted in which trig function you can use. I'm going to start off by labeling my sides. Opposite of the right angle is hypotenuse. Opposite of R is obviously the opposite side. And right next to R is adjacent. So I'm taking a look at this. Relative to angle R, I have adjacent and hypotenuse. So remember SOHCAHTOA, and we have to decide which trig function uses adjacent and hypotenuse. And that's going to be the cosine. So that's how I choose which function I use, depending on what you're given. The cosine of R is going to be adjacent, which again is radical 3, over hypotenuse, which is 2. Put those parentheses inside the radical, so you know that R is going to be the inverse cosine of radical 3 over 2. And when you process that, you should end up with R being equal to 30 degrees. So we're going to practice setting these up in class. We're going to get the calculators out and take a look and see what mode we need to be in and what buttons we need to press to start working on these trig ratios.